Okay, so our last three problems are all about circles, so I went ahead and wrote the formula for the circle at the top of the paper. X minus h quantity squared plus y minus k quantity squared equals r squared, where hk is the center and r is the radius. So number 18 says, write the equation of the circle with a center at -8, 2, that's the center, which is my hk, and has a radius of √7, which is my r. Now, after you get that equation, leave it in standard form, don't distribute it out. So I have x minus h quantity squared. But who is my h? Well, in this case, my h is -8. There's a blue minus from the formula and the negative, a red negative from the 8. Plus y minus k squared. And who's k in this problem? Well, k looks like it's 2, positive 2. But there's a minus, a blue minus from the formula, and a positive 2 for the red, equals r squared. Now, r is √7, so I have √7 squared. Okay, so this can be cleaned up a bit. I can rewrite the x minus a -8 as really x plus 8. Y minus 2 squared, that just comes down. And the square root of x squared and the square root of √7 squared is just 7. That's my final answer. On the next problem, I have an equation of a circle, but it's not in vertex form or standard form here. So what I need to do is I need to take this long general form and put it into standard form. So what I'm going to do is I'm going to gather up all of the x's and put them together. X squared minus 4x, and then I'm going to leave a little space so I can complete my square. Then I'm going to gather up all the y's, so I have y squared plus 6y, and then I'm going to leave a little blank so I can complete my square. And lastly, I'm going to move the 4 to the other side by adding its opposite. Now, in order to complete the square, I need to add some numbers in here. Now, if I add them, I have to then add the same value to the other side of the equation so that I keep my equation balanced. But the completing square process is divide by 2 and square. So when I take -4 and divide it by 2, that gets me x minus 2 quantity squared. That's where I'm getting the -2 from. Now, in order for that to be true, I need to put a value up there. And the value that needs to be there is the -2 squared. -2 times -2 is positive 4. Notice this number is always positive, so you don't have to worry about signs there. It's always going to be positive. All right, let's do that again. Plus y plus some number squared. And how do I get that number? I divide by 2. So 6 divided by 2 is 3. 3 squared gets me 9. Again, it's always positive. If I add 9 to the left, I also have to add a 9 to the right. When I add up all of the values on the right-hand side, -4 plus 4 is 0, plus 9 is 9. That gets me my standard form, x minus 2 squared plus y plus 3 squared equals 9. Now, to get the center off that standard form, I need to get the hk. Now, because there's a minus in the formula, I'm taking the opposite signs, which is a theme throughout all of college algebra. Anytime you have an x and a number next to each other and you're pulling off the number, it's the opposite sign. So y plus 3, I take the opposite sign, which is -3. The radius, I'm going to take the square root of 9 because on the right-hand side is equals r squared. So what is the r if r squared is 9? Well, r must then be 3. To plot this, I'm going to go to 2, -3. My radius is 3, which means I'm going to go up 3, right 3, left 3, down 3, and draw a circle. Now, a lot of students will just connect the dots and make it look kind of like a rounded off square diamond-like thing, but this isn't baseball. We're not drawing diamonds, okay? We want to make those arcs as archy as you can so that you're actually making a circle and not just a rounded off diamond. Like if you were like in baseball. You run straight and then curve and then straight and then curve and then straight and curve. That's not what we want. Okay, we want a nice circle with a radius. I know that's not perfect. It's not beautiful. I'm not expecting beautiful, but I am asking you to be aware that a radius goes all the way around the circle and not just up, down, left, right. Our last problem is already in standard form, yay. So all I need to do is pull off the center. So the opposite of -4 is +4. The opposite of +2 is -2. So I have a center at 4, -2. Now what makes this one hard is we have to equal r squared on the right hand side, but I don't know what the square root of 19 is. Now you might have a calculator with you and you might not. So I'm going to show you how to do it without a calculator. I want you to find a perfect square that you do know around 19. Well, I know that the square root of 16 is 4, and that's below 19. I know the square root of 25 is 5, which is above 19, which means the square root of 19 is 4 point something. Okay, so I'm going to just write the radius as the square root of 19, but when I go to my circle and I'm trying to graph it, I can't graph root 19. It's hard to do, but I can graph 4 and a little bit. So I'm going to go up 1, 2, 3, 4, and then a little bit more. Down 1, 2, 3, 4, and then a little bit more. Right 1, 2, 3, 4, and a little bit, and then left 1, 2, 3, 4, and a little bit. Okay? And then I can already have my arc started here. That one's off a bit. And then just connect those arcs with more arcs. Okay, and there's your circle with a center at 4, -2 and a radius of the square root of 19.